All right, so today we are going to talk about complex numbers. So you're going to learn what an imaginary number is, what a complex number is, how to graph a complex number, and how to find its absolute value. So we're going to start off with an imaginary number. What is an imaginary number? It's a number that when squared gives a negative result. So basically I equals the square root of -1. And we always use I to represent an imaginary number. That allows us to simplify negative square roots, or the square root of a negative number. So the square root of -25 is, if you break it down, -1 times 25. So the square root of -1 is I, and the square root of 25 is 5. So it's plus or minus 5i. Okay. If I were to simplify square root of -120, again, it's -1 times 120. So we can take the I out and then simplify 120. 120 is 12 times 10, 2 times 5, 4 times 2, 2 times 2. So we're going to pull out 2 pairs of 2's. So we're going to get plus or minus 4i root 5. Put an extra I in there. So it's positive or negative 4i root 5. Okay. So with an imaginary number or complex numbers, they follow this pattern. I is equal to I squared, we just said, equals -1. I cubed equals -I to the 4th equals 1. And then the pattern starts all over again. So I to the 5th is 1, I to the 6th is -1, I to the 7th is I to the 8th is I, and so on and so forth. It always repeats itself. So if I was going to simplify I to the 21st, I would look at what the closest multiple of 4 is. So this is I to the 20th times I to the 1st. Okay, I to the 20th is a multiple of 4, so it's just 1. Okay, then I to the 1st is I, so this simplifies to I. Okay, I to the 75th is the same as I to the 72nd. That has, if I divide that by 4, it has a remainder of 3. So times I cubed. Okay, 72 is 1. I to the 72nd. I cubed is -I. So I to the 75th simplifies to -I. I to the 24th is a multiple of 4. So that means that it just simplifies to 1. Okay. Notice that I made my I's in cursive and put a dot over it so it makes it easier to read. Now, a complex number is any number of the form a plus bi, with the real part coming first and the imaginary part coming second. And these are just examples of complex numbers. 2i, 3 minus 2i, and -4 plus 5i. We can graph them on a number plane that looks a lot like the Cartesian plane that we're used to. But instead of x and y, we have our real numbers along the x-axis, in our imaginary along the y. So to graph -2 plus 3i, I'm going to go over -2 on the real axis and up 3 on the imaginary. So this is -2 plus 3i. Okay. To graph 5 minus 4i, I go over 5 on the real and down 4 on the imaginary. So this is the point 5 minus 4i. If I want to graph -2i, I'm not going to go anywhere on the real, and then I'm going to go down 2 on the imaginary. So it's 2i. So that's how I graph an imaginary or complex number. All right, so you might recognize part of this because you've learned about the real number system. The complex number system encompasses both the real number system and then imaginary numbers. So real numbers now, besides being real, are also complex. Okay, imaginary, straight imaginary are called pure imaginary. So a pure imaginary number would be like I, 3i, negative 5i. And then the complex would be the a plus bi. So the complex encompasses all the numbers that we've had. Okay. All right, so additive inverses, just like with numbers, add to 0. So like negative 3 plus 3 are additive inverses because their sum is 0. The same goes for additive inverses in complex numbers. So negative 3i plus 5, which isn't written correctly, should be written as 5 plus 3i, negative 3i, so minus 3i. The additive inverse of that would be negative 5 plus 3i. And then negative 5 minus 7i, the additive inverse of that would be 5 plus 7i, because when we add those together, we're going to get 0. All right, so now to find the absolute value of a complex number. Okay, let's say that I have this point right here. I'm going to like that point. Let's go with this point right here. Okay, that point, because this is the real number and this is the imaginary, is 3 plus 4i. Remember, absolute value is the distance a number is from 0. So we're going to take the shortest distance, which is this diagonal right here. All right, and you can find that distance either using the distance formula or a plus b squared, a squared plus b squared. So a is this distance right here, which is 3, and b is the coefficient here, which is 4. So all we're really doing is the Pythagorean theorem. So it's just the square root of 3 squared plus 4 squared. So it's 9 plus 16, or the square root of 25, or 5. So the absolute value of this is 5. We're not going to change the decimals. We're going to leave them in simplest radical form if we need to. So what did you learn today? You learned what an imaginary number is. You learned what a complex number was. You looked at the systems. You learned how to graph it and how to find the absolute value of a complex number. Have a math-tastic day.